Good morning, everyone. Myself, Monica Nansikia, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W25C01, Basic Electrical and Electronics Engineering in the Regulation 2025. Today, we are going to discuss the topics of electrical engineering. Before learning the complex machines, circuits, we must understand the fundamentals. So, first, what is DC? The DC means the direct current. So in DC, the current flows only in one direction only. So if the current only flows in one direction, for example, battery, cell, power bank, these are the current flows only in one direction only. This current from the mobile battery is AC or DC. Think about it. Yeah, it is always a DC. So the current in the battery is always a DC. So in DC circuits, voltage polarity does not change with time. That is why it is simple and easy to analyze. To understand the DC circuits, we must understand the basic components. So first and most important component is the resistor. What is resistor? A resistor is a component that opposes or limits the flow of electric current. So how to oppose the flow of current? If you want 2 amps current only, you want for the load. So if we put resistor in the middle of the load, it oppose or it limits the flow of current for the load. So what the current needed for the load, then the resistor will supply. So the unit is ohm and the symbol is here they are mentioning the symbol. So the unit of resistor is ohm. So what are the uses of the resistor? What is the use? How it is denoted? And it is denoted as R. So now explain the concept. When the current flows through a resistor, the electrical energy is converted into heat energy. So for example, electric heater, iron box, toaster, in these all the elements we are using the resistor only. So why does the heater becomes hot? Because the resistor converts electrical energy into heat. So the important is the Ohm's law, V is equals to IR. If the resistance increases, the value of the resistance increases, the current decreases. So that's the meaning. What is the if we increase the value of the resistor, it increase the opposing, it increasing the limitation. So the current will get limited. So the application is the current limiting in diodes, that is LED protection, voltage divider, and current limiting. So if we connect LED directly to a battery without the resistor, what happens? It burns. So the resistor is a protective component also. Then the inductor. So what is inductor? An inductor stores energy in the form of magnetic field and it creates in the magnetic field. Why? The inductor is like a coil. We have the coil in the device which shows that the symbol which shows it's a coil and its unit is Henry and it is denoted as L. So because of the coil, there is a magnetic field occurs because the coil it's made up of iron, no? So it creates a magnetic field. So the symbol is also the coil. When the current flows through the coil, it creates a magnetic field around it. So the inductor opposes the sudden change in the current. For example, when you suddenly switch off a fan, sometimes you see spark. That is because a inductor releases the stored magnetic energy. Suddenly you switch off the fan, it will get a spark. So the inductor is drastically releases the stored magnetic energy. For the uses are the transformers, it is mainly based on the inductor, and the filters, relays, and motors, which is always use the inductor only. So where do we see the coil in the real life? We see the coil in the motors, no, in motors, transformer. In that you have to watch that, you have to see that coil which is wound on the motor or transformer. In the capacitor also, the motor is also, the coil is also wind in the fan, the capacitor. Then the comparison is, what is the resistor? It opposes the current. What is the inductor? It opposes the change in current. Okay. Next one, third one is the capacitor. The third basic component is the capacitor. This capacitor stores energy in the form of electric field. Here there is no magnetic field, there is no magnetic effect because in inductor only the coil is present, but in the capacitor there is no coil. So the unit is farad and it is symbol is this and it is denoted as C. So the capacitor has a two plates because of this, so that the symbol should be written like this. The capacitor has two plates separated by an insulator. So it stores charge between the plates. The capacitor opposes the sudden change in the voltage. For example, in mobile chargers, capacitor smooths the DC output for application. The main application for the capacitor is power supply filters, timing circuits, signal coupling. So these are the very important comparison. Try to remember the three components. What is resistor? If the resistor is used to control the current. What is the inductor? It opposes the changing current. What is the capacitor? It opposes the changing voltage. So these are the comparison. You have to know the basic components are these. Next one is the electrical network. What is an electrical network? The electrical network is an interconnection of electrical elements like R which is connected to the L and L which is connected to the C and C which is connected to the R. The basic component is R, L and C, that is resistor, inductor and capacitor. If one component is connected with the other component, that is known as the electrical network. So these are said to be the interconnection of electrical components. So we are having types of electrical networks: active network, passive network, linear, non-linear, bilateral, unilateral, lump, distributed, time invariant, and variant. What is the active network? It contains at least one source, that is battery. So, for example, if we connecting battery plus resistor, it can supply power. So, it is said to be the active network. Then passive network. In this passive network, there is no energy source will be provided. Only element, that is resistor, inductor, and capacitor. So it can't generate power, it can't generate supply because there is no energy source will be given. No. So we are connecting resistor, inductor, and capacitor. This is the passive network without any energy source, so it cannot generate power also. Next one is the linear network. What is linear network? The linear network always obeys the Ohm's law. So the output is proportional to the input. So always the output is directly proportional to input. So we have the linear VA characteristics. So for the example, we have the fixed resistor circuit. If you have one circuit that is the fixed, there is no changes in the circuit. That is the linear network. Next one is the non-linear network. In linear, what we say, we say that the Ohm's law obeys the for the linear network, but in non-linear network, it does not obey the Ohm's law. For example, diode, transistor. If the diode is linear, if we change one thing, it will the current will change, the voltage will automatically change. No, the diode is not like that. So the diode is the example for diode. Transistors are example for the non-linear network. Next one is a bilateral network. What is bilateral? It works same in both the direction. Example RLC, because the current flow which is in the same in the both directions. So it is named as a bilateral. Bi means both. Yeah. So that we are having that RLC network is the example for the bilateral network. Next one is the unilateral network. This is it is completely contrast for the bilateral. What is unilateral? It behaves, it depends on the direction of current by the network behavior. How the network behaves, that depends upon the direction of the current. For example, diode. Diode will always flow the current only in one direction only. So the example of unilateral is diode circuit. Next one is the lumped circuit. In lumped circuit, the circuit parameters are assumed to be concentrated at one point because it's a low frequency circuit. So the circuits are assumed to be concentrated at in the one point only. What is the distributed? Distributed means it can be distributed, it can be sharing. So the parameters like resistance and capacitance are distributed along the length. For example, the transmission line. Transmission line in our roadways, we are always see the transmission line, coaxial cable. So it is a distributed network. Okay. Next one is the time variant, time invariant. What is mean by time invariant? The network parameters do not change with the time. So whatever the changes, whatever we changes, we have changing the resistor value, inductor value, it does not change with time. So it is an example for the fixed resistor circuit. And the time variant is it's the opposite. Whatever the time changes, the network parameters also changes. So it's example for the switching circuits. Then the resistors or in series. What are the resistors are connected in series and parallel? In series connection, resistors are connected to end to end. The important point is same current flows, but the voltage divides in the resistor in series circuit. So the total resistance is increases. What is the formula? The R equivalent or R total is equal to, here the resistance are connected in series one by one. So the resistance, we have to add the three number of resistors, that is R1, R2 and R3. So the current through the all resistor is same. For the resistor, this is connected in series, the current through all the resistor is same, but you are having the individual voltage drop for the individual resistor. You are having V1 voltage for the voltage drop for the resistor 1. You are having V2 voltage drop for the resistor 2. You are having V3 voltage for the voltage drop for the resistor 3. So we are having different voltages in the resistance while we are connecting the resistance are connected in series. For example, if we are giving the resistance R1 is equal to 5 ohm, R2 is equal to 10 ohm, and for the total is R1 plus R2, that is 5 plus 10 is equal to 15 ohm. This is also use the voltage divider circuits and current limiting. Next one is the resistors are connected in parallel. In parallel connection, resistors are connected across the same points. Here R1, then R2 and then R3. Here, the total resistance is equal to 1 by R1, the reciprocal of the sum of the resistor, that is 1 by R1 plus 1 by R2 plus 1 by R3. So, in this, the current divided across the resistor. Here, the current will get divided. Here, I1 current will flow, I2 current will flow, I3 current will flow. But in voltage matters, there is no voltage present across the R1, R2, R3. There is the even voltage present across the R1, R2, and R3. So in the parallel circuit, the voltage is same and the current divides. So the total resistance values decreases. Formula is 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here also we are having a small problem. R1 is equal to 10 ohm, R2 is equal to 10 ohm. So 1 by R1 plus 1 by R2 is what? 1 by 10 plus 1 by 10. So R total is equals to 5 ohms. In our household, what wiring, what supply, what connection we are giving in our household material, house. Yeah, yes, we are connecting in a parallel connection only. In our house, we are connecting a parallel connection so that the even voltage will be shared for the light, fan, tube lights, washing machine, so that evenly the voltage will be shared across the all the equipments of our house. Okay. Next, what are the topics we have discussed? In this, we have discussed about, in this session, DC fundamentals, we have discussed resistor, inductor, capacitor, types of electrical network, what is the series and parallel resistors. So these basics are very important. If you understand this clearly, future subjects will become very easy. We will see the next topics in our next classes. Thank you.